Hello everyone, we will be presenting on adsorption application for water purification and drinking water treatment. This is our project-based learning 2 assignment for the course ECH 3126 Unit Operation. Before we dive into the technical details, let me introduce our team. We have Afif Mutaki, Imran Azmi and Shuko. Okay, so let's start with the problem. Every day, millions of people turns on their taps expecting clean water. But the reality is that our water sources are increasingly contaminated with that scientists call emerging contaminants. There are 5 main categories of pollutants we need to worry about. First, pharmaceuticals, things like antibiotics, hormones, and painkillers that enter our water through human excretion and proper disposal of medicines. Second, pesticides. Agricultural chemicals like herbicides that run off from farms into our rivers and groundwater. Third, PFAS, also known as forever chemicals. These are synthetic compounds that never break down in the environment. Fourth is industrial chemicals, various synthetic compounds from factories and manufacturing plants. And fifth is disinfection byproduct, harmful compound that form during the chlorination process at the water treatment plants. So the problem is that conventional treatment plants were never designed to remove these substances. And even in tiny amounts, these contaminants can cause serious health issue, cancer, nervous system damage, and hormonal destruction. They also harm aquatic life and disturb entire ecosystem. So what is the solution? The answer is adsorption technology using activated carbon. Activated carbon is made from natural material like coconut shells, bamboo, or wood. When these materials are heated to very high temperature, they develop millions of tiny pores. This gives activated carbon an enormous surface area. Here's mind-blowing fact that 1 teaspoon of activated carbon has the same surface area as a football field. That's why it can trap so many pollutants. It works like magnet but at a molecular level. The process is simple. Contaminated water flows to the activated carbon. The pollutants are attracted to the carbon surface and stick to it. Then clean water flows out. There are 2 forms used in water treatment. First is granular activated carbon or GAC. This works like sand in a filter. Water trickles through slowly, giving pollutants time to stick. And second is powdered activated carbon or PAC. This is mixed directly into the water, then removed later with the pollutants attached. So, why choose activated carbon? It's effective, uses agricultural waste that would otherwise be thrown away, and it's a proven technology. It removes pollutant that all treatment plants simply can handle.
Let me explain adsorption. Imagine a piece of Velcro. The tiny particles touch it, they stick to the surface. That's exactly what adsorption is. Molecules sticking to the outside of a material. It's important to know that this is not like a sponge that soak water inside. Adsorption only happens on the surface. You have seen adsorption many times. Cold water filter work this way. Those little silica gel package that come with new shoes, they absorb moisture from the air. Even aquarium filter use this process. So in simple terms, adsorption is when harmful chemical and water attach to a special material and clean water pass through the contaminant stick and the water gets cleaner. Now let's talk about diffusion. This is the movement of molecule from crowded areas to less crowded areas. It happens all by itself. We don't need to push or force anything. Think about opening a perfume bottle. The smell spread across the room without you doing anything. That diffusion. In water treatment, contaminated water has many contaminants. but near the absorbent material there are fewer contaminants because some have already been captured, so naturally more containment move toward that area. They come closer to the absorbent all on their own. Once they get close enough, that's when absorption happen. They stick to the surface, so diffusion bring them in, and absorption locks them down. Together, they clean the water.
Now, I'll discuss the environmental impacts of activated carbon absorption. First, this technology provides environmental benefits because agricultural waste such as coconut shells and bamboo can be converted into activated carbon instead of being discarded. This supports a circular economy and reduces waste. Activated carbon also improves water quality by removing contaminants such as PFAS, pesticides, and pharmaceutical residues, helping to protect aquatic ecosystem. However, there are challenges, such as producing activated carbon requires high temperature and large amounts of energy, which may increase greenhouse gas emissions if fossil fuels are used. In addition, used carbon must be regenerated or disposed of properly to avoid creating secondary pollution. Overall, activated carbon can support environmental sustainability, but only when energy use and waste management are carefully controlled. Next is societal impact. The biggest benefit is improved public health because cleaner water reduces human exposure to harmful contaminants. This technology can also create economic opportunities by turning agricultural waste into valuable materials and creating jobs for operating and maintaining treatment systems. However, advanced treatment systems increase operating costs and require trained workers. Public awareness and strong regulations are also important to ensure communities understand and support the technology. Overall, activated carbon absorption can improve quality of life, but successful implementation depends on balancing health benefits, costs, and community involvement.
Okay, based on our analysis, we recommend using activated carbon absorption for drinking water treatment. However, successful implementation depend on several important conditions. First, pilot scale testing should be carried out before full scale installation because water quality may differ from one location to another. Testing help determine the best operating condition and reduce the risk of expensive implementation mistake. Second, renewable energy should be used during activated carbon production and regeneration whenever possible. This reduces greenhouse gas emission and improve the overall sustainability of the technology. Third, a stable supply of agricultural waste such as coconut shell and bamboo should be established. This renewable energy can produce a high quality activated carbon, but continuous stability is necessary for long term operation. Finally, local communities should be educated and involved throughout the implementation process. Open communities help build public trust, address concern, and encourage long term acceptance of the technology. In conclusion, activated carbon absorption is an effective and practical technology for improving drinking water quality. With proper testing, sustainable operation, and community support, it can help protect both public health and the environment. Thank you for listening.